Hi, my name is K. Nagamalikarjuna and I am submitting my final project for data engineering and mining. I have taken here a dataset breast cancer WinSCON from the user repository as mentioned in the project instructions. The problem, the goal of this project is to develop a machine learning model that can accurately diagnose breast cancer based on a set of features extract from a fine needle aspirate images. This has real-world applications in the medical field where early detection and accurate diagnosis of breast cancer can significantly improve the chances of successful treatment. The breast cancer viscount dataset contains information of 569 images where each image is described by 30 features such as texture, perimeter, and concavity. The target variable is the diagnosis, which can be either benign or malignant. Here, to approach this problem, we can use both classification and cluster algorithms. Initially, for the classification algorithms, there are so many techniques, but we use the support vendor mission and we develop a model that can accurately classify FN images as benign or malignant based on their features. Secondly, we'll make a clustering algorithm such as k-means, which can be used to identify subgroups of patients with similar features. This can help in identifying different types of breast cancer and identifying patients who may require different treatment strategies. First step, a classification algorithm. Here we use the classification model of the support vendor missions. We will read the code, the breast cancer dataset from user repository, which contains various features of tumors. In the first part of the code, we import the necessary libraries for data analysis and machine learning, such as Panda, NumPy, and Skyline. So we have imported the libraries for the analysis, Pandas as PD and NumPy as NP, and for the metrics, for the processing, for the pipeline, and for the plotting MATLAB. Here we have split the data and we have loaded the data from the user repository and we have split the data into features and target by and convert the target variable to binary and we have split the data set into training and training sets. Then we will scale the features using the standard scaler and we print the data. We got 0 to 31, 32 columns and 569 rows. Next, we create a SVM model that fit into the training data. Then we make the predictions, then we calculate the accuracy, then we define a grid hyperparameters, then we search with a 5-fold cross validation, then we'll print the best parameters and test score. We got the accuracy 0.197 and the test score 0.908. Then we make the predictions on test set and we print the classification report. We got the precision, recall, F1 and the support as 198, 198, all the things. Last, we define the SVM model with RBF kernel function and we define the hyperparameter grid and we will fit the grid with the training data and we extract the results from the grid sets and we extract the values of the hyperparameter gamma. Then we'll plot the test score against gamma, then we'll label the plot and we'll show the plot using the function show. Yeah, we got the plot with the hyperparameter tuning for SVM with the RPL kernel function. Lastly, we create a SVM model, SVM with an RBN kernel and the optimal hyperparameters. We will fit the SVM to the training data, we'll make the predictions on the same things. We got the final report. So overall, the code demonstrates how to create a SVM model to classify breast cancer tumors and optimize its performance using hyperparameter tuning. Second step, clustering techniques that use the k-means. The same things, uh, we will import the main libraries and we will load the data and we will print the data and we'll separate the data into features and labels and we'll make the data processing and we visualize the data using the plot function. Now we'll get the clusters using the k-means clustering and we'll make a elbow method for I in range I to 1. We'll make the iteration and we'll append the values and we'll make a plot and we'll make the label and we'll make the elbow model. We got the elbow model. Lastly, we'll make a cluster diagram to link the data, points and the distance. Experimental design. So now we have created a classification and a clustering model. Now we'll do a experimental design. So we do by this experimental comparison the SVM and the k-means using the breast cancer dataset. We'll first do the investigation. We'll make the data preparation. First we will load the data and import the libraries and drop the unnecessary columns and split the data into X and Y and we normalize the features and we split the data into training and test data. Then we will train a SVM model on the data. We will use the RBF kernel and to the hyperparameters using a grid search with cross validation. Then we will print the best parameters and accuracy. We got the 0.95 best accuracy. Then we use the finally k-means to cluster the data into two groups corresponding on the two diagnoses, malignant and benign. Then we will use the elbow method to determine the optimal number of clusters. We import the function libraries and we define the k-means model. We define the optimal number of cluster using elbow method. We got the accuracy 0.089. So we have normalized the features and we have the split the data and we define a k-means model and we convert the labels into string variables and we have evaluated the k-means performance using accuracy and confusion matrix. That here the k-means model achieves an accuracy of 0.085, that 85%, which is decent, not good as SVM. The confusion matrix shows the miscalculate some overall. In investigation, we compared the performance of SVM and k-means algorithms. We found that the SVM outperformed the k-means in terms of accuracy, however, could still be useful for so we got the SVM the best model. Now, we done an experiment with tuning parameters of the algorithms. For this, we take an SVM algorithm, we use the grid search to perform a grid search over a range of hyperparameters. Then we will tune the regulation parameters and kernel parameter gamma for an RBN kernel. So we got the best parameters and we got the best accuracy 0.95. For the k-means, we will tune the number of clusters using the elbow method. Then we use the optimized number of clusters to train the data. Here, the elbow method suggests that the optimal number of clusters is 2, which is same as the clusters in the data set. Here, again the k-means achieves 85 point, which is same as the previous experiment. So in conclusion, this experiment with tuning parameters, the SVM k-means algorithms on the data set, the SVM using grid search can improve the accuracy of the model. So the SVM finally outperforms the k-means. Thank you.